All right, in our 8-4 notes, we're looking at trapezoids and isosceles trapezoids. Okay, so we'll go basic first and then we'll get more specific. So in a trapezoid, the first thing, there's going to be a lot of things to label, but the first thing that we need to recognize is that bases are parallel. Okay, so let's go to our picture and label a couple of things. So first we'll call this base 1, and for equations I'll do b sub 1. Make sure you understand that's a subscript. And then we'll call this base 2, and so we'll call it b sub 2. It really doesn't matter which one you call b sub 1 and b sub 2, just as long as you know that there are two of them. So you have to know by definition that those are parallel. Sometimes you might want to draw in the arrows to remind you. Again, look at that picture, guys. Arrows mean parallel. They don't mean equal in length. You can definitely tell there those bases are not equal in length. Okay, so those are the bases, the ones that are parallel. The other two sides in a trapezoid are called legs. Okay, so this is a leg, this is a leg, and understand, I just like you to see it right off the bat. This could be drawn differently. Sometimes the trapezoid is drawn maybe looking a little bit like this. Okay, so that's still a trapezoid. It would still be these two sides that are parallel to each other that would be the bases. Okay, and the other two sides would be the legs. Okay, so don't let it throw you off however it is drawn. Okay, then next. Okay, so this one's a little bit hard to describe, so you might want to just listen and watch my abbreviations, and then you can add the details. I'll give you a moment to add the details to yourself. So here's how I'm going to write it. I'm going to say LBAs, which is going to stand for lower base angles, and I'll label that in my picture in a minute, and UBAs, upper base angles, are supplementary. And we know supplementary means they add to 180. Okay? But I'm going to make the stipulation that we're talking about side pairs only. Okay. So let's go and do some labeling. Here we go. So upper base angles would be these that are here with the upper base. So they would be angle A and angle B, the way I have it drawn right now. Lower base angles would be these two, angle D and angle C. And I'm just using those abbreviations, LBAs and UBAs. So lower base angles and upper base angles. Now what I mean by side pairs only is the following. If you just went to this side, meaning this leg, I'm not going to draw over the whole thing because I want to erase it. But if I just went to this one leg, these two that are connected to it, the upper base angle of A and the lower base angle of D, are supplementary. Okay? And likewise, over here, the upper base angle and lower base angle that are attached to that leg, that side, those are supplementary. So angle B and angle C. Okay? Those are the only ones that are supplementary to each other. So I'll take that out to not complicate our picture. And here I will say we're talking angle A and angle D are supplementary, and angle B and angle C are supplementary. Okay, so I'll give you a moment to write in, draw in what you want to be able to explain it for yourself. Okay, next, let's talk about a median. Okay, so A median is really what it's called, but we're going to use capital M to stand for median. Okay, so a median in a picture goes right through the middle of this trapezoid. Okay, so there's a couple of things for you to realize. So one, we'll put it here. This is a median. And we'll go ahead and tell you one of the things that you need to know about a median. Okay, I'll just go ahead and put it on this line. A median is parallel to the bases. Okay, and the bases are both parallel to each other, so we can just add another arrow, if you will. So all three of those, base 1, the median, and base 2 are all parallel to each other. That's important to keep in mind. All right, but as far as how it's related, so first of all, recognizing a median. A median cuts the legs in half. We said it goes through the middle of the trapezoid, but it cuts each of the legs in half. Okay, so you know you have a median if either somebody tells you it's a median or you see this in the picture. These two parts being marked the same, right, because it's cutting through that leg, and maybe these two parts marked the same because it's cutting through that leg. So both of those things would tell you that it's a median. Okay, now as far as its relationship to the trapezoid, a median is 1/2. Go ahead and keep that horizontal fraction bar. 1/2 of the sum of the bases, meaning you would add b sub 1 plus b sub 2 and divide by 2. Okay, now that's the way it's usually written. However, for ease, right guys, that's times. So you could think of the b sub 1 plus b sub 2 over 1. And if you multiplied straight across, sometimes it's easier for people to just write this as b sub 1 plus b sub 2 all over 2. That's the same thing, okay, just in a different form. So you will be using that to calculate things. Okay? Now, a more specific type of trapezoid called an isosceles trapezoid, right? We've seen isosceles triangles and what that means, right? In an isosceles triangle, you have two sides that are equal. Well, guess what? In an isosceles trapezoid, you also have two sides that are equal. The only sides that could be equal would be the legs. Okay, so isosceles means the legs are equal. So we're going to come down to this picture. We'll mark both of those equal right off the bat. Of course, it's a trapezoid, so of course it's going to still have those basic characteristics, right? Like bases are parallel to each other. Okay, that's not going to go away. And then it's still true, okay, about the side pairs only, but this one's going to be become a little more specific based on the information that we're going to give you about isosceles trapezoids. So here's what you need to know about isosceles trapezoids, is if those legs are equal, then all of a sudden the lower base angles become equal to each other. Okay, my lower base angles are which letters? Right, D and C. So we're saying angle D equals angle C. Okay. And then my upper base angles are also going to be equal. That's the property. So specifically in this one, that would be what? Angle A would equal angle B. Okay, well then we can be a little more specific than we were in the trapezoid. Now we're going to literally be able to say that any lower base angle and any upper base angle are supplementary. Okay, so we said the lower base angles are equal to one another. The upper base angles are equal to one another. We need to make them a different marking. And now if you kind of go through and make your pairs, well, we know if you stick on one side, it works, right? So we know that like angle A and angle D are supplementary. That's always safe for any type of trapezoid. So is angle B and angle C. safe for any type of trapezoid, right? Because it's on one leg, left side and right side. But now, because of the markings, since angle A and angle B are the same, I can replace that angle A in the top with this angle B and say, all right, angle B and angle D would be supplementary. And in that second line, angle B and angle A are interchangeable, so now angle A and angle C are also supplementary to each other. All right, so still specific to any kind of trapezoid. Okay, so we can't leave this out. A median, which we're still going to use capital M. The median, which I'm not drawing in the picture, guys, because it's going to get more complicated quickly, is still half the sum of the bases. Remember, those are subscripts. And you're welcome still to write that as b sub 1 plus b sub 2 all over 2, if it helps you with the algebra that will be coming up with those. Okay? All right, next, more specific to an isosceles trapezoid, and that is about the diagonals. So the diagonals are equal. Okay, let's go draw those in. So this diagonal from A to C, and this diagonal from B to D, those are equal to one another. Okay, but the other important part of that is this. The upper part of the diagonals are equal, and the lower part of the diagonals are equal. So let's go over to the picture and mark what we're talking about. Okay, the upper part of the diagonals, by that I mean from A to where the two diagonals cross, and B to where the two diagonals cross. That's what I'm calling upper parts. And the lower parts, from D to where they cross, and from C to where they cross, are equal. So the upper part of the diagonals are equal, the lower parts of the diagonals are equal. Okay, and that's everything you need to know about trapezoids and isosceles trapezoids. So again, guys, once again, you either have to be told something is a trapezoid or an isosceles trapezoid, or somebody has to mark something specifically enough for you. Okay, so purposely, I'm not telling you what these are. Okay, you've got to be able to infer it from what's given to you. So here we go. Let's say for this first one, I give you 3x plus 70, and understand what I'm labeling is angle A, okay, when it's written that way. And then we'll make this 5x plus 30. And that's angle D, okay? We're asking you to solve for x, angle A, and angle B. Okay? All right, so if that's all that's in the picture, is that a trapezoid or an isosceles trapezoid? Remember the tip-off that it's an isosceles trapezoid. Remember, don't trust the picture. It's got to be with the markings. Would have the legs marked. Or the lower base angles equal marked. Or the upper base angles equal marked. I don't see any of those things. So I have to just make the assumption that this is just a regular trapezoid. Okay, so the only thing I know about an upper base angle and a lower base angle in a trapezoid is that if they're on one side, they are supplementary. So I'm going with 5x plus 30 plus 3x plus 70 equaling 180. Here's my equation. So 5x and 3x, I've got 8x plus 100 equals 180. If I subtract 100 from each side, I have 8x equals 80. Divide by 8, x will equal 10. They did ask me to solve for x, so I'll go ahead and box that. And again, what was my property? This is what you can do for abbreviation. I'll know what you're doing if you say LBAs and UBAs supplementary. Okay, yes, it's only on one side, but I'll know what you're talking about. Lower base angles and upper base angles are supplementary. And then angle A should just be plug and chug, right? You've got 3 times 10, you show that with parentheses, plus 70. Okay, clean that up a little bit. So that means angle A is order of operations, multiply before you add. 30 plus 70 is 100. It's an angle, so it needs to be 100 degrees. Okay, beautiful. And then angle B, sometimes I like to go put in the picture what I just found. So I found that this is 100 degrees. And I'm going to think immediately, well, I know immediately angle D, right? 'Cause staying on that same side, I know they're supplementary. That was the equation I used. I know angle D is 80 degrees, right? Because 100 plus 80 would be 180. Do I know anything else? And I noticed they're asking me angle B. Angle B is not attached to that side, right? And therefore, since it's not isosceles, I absolutely can't do anything with angle B. So the answer for angle B is just can't determine. That's the answer. Okay, don't get too fancy and tell me like can't be done or no solution or I don't know. It's just can't determine. You can't do it. You don't have enough information. Okay? All right, next, let's go with this picture. And this should say, sorry, that didn't connect. That should say B. Okay. But anyway, here's the information that we want to give you. I'll put it in blue this time. Let's give you this angle's 30 degrees. This length is 12, so we'll just circle our given information. How about that? This length is 5 root 2. Angle C is 45 degrees. And I think that's enough information. What I would like you to do is find perimeter. What's perimeter mean? Perimeter means distance around the outside, right? So I want you to find the perimeter of trapezoid ABCD. Find the perimeter of trapezoid ABCD. Okay? All right, well, here's what you want to do, guys. At the start of every single problem that's a trapezoid, you should treat it as a rectangle and 2 triangles. Okay, and so here's how you do that. You're going to drop an altitude from this upper base down to here, and another one from that corner down to here. Remember, altitudes meet sides at right angles, so you're going to go ahead and put in that right angle and this right angle. So I hope you see that as a, on the left, looks like a 30, 60, 90 right triangle to me. On the right, it looks like a 45, 45, 90 right triangle to me. And in the middle, I've got a rectangle. All right, well, following rectangle properties, this would be the easiest part to find. If A to B is 12, then this part from the right angle to the right angle is also 12. In a 30, 60, 90, guys, I need to have at least one of the sides. So I'm going to go to the 45, 45, 90, because that's the only one that has some information right there given to me. Okay? I only need one side on a 45, 45, 90 also. So if the hypotenuse is 5 root 2, I get the legs by I want to get shorter, so I should divide by root 2. Okay, we've done the pattern enough that you should know in this 45, 45, 90, this would just be 5. And likewise, this part would be 5 from the right angle to the C. All right, back to the rectangle property then. If the right side of the rectangle is 5, then the left side is 5. Now all of a sudden I have one side of my 30, 60, 90 triangle, which will let me solve for the other two. Okay, if that's the short leg, then the long leg, I want to get longer, so I should multiply by root 3. So 5 root 3. Again, go back to the short leg of 5. To get the hypotenuse, I should multiply by 2 to get 10. All right, I've literally found everything, guys, which means when I say find the perimeter, it means start one place and find me the distance all the way around the outside. Okay, so if you just start one place, like A, and just kind of trace around the outside, right, and say 12 plus. I don't want to miss anything, so I just kind of trace it, is how I do it for myself. Plus 5 root 2 plus, well, this is 5. So if you really want to do them separately, you can. Plus 12 plus 5 root 3 that we found in red plus 10 will get me back to where I started. Okay, so there's what I'm doing visually for myself. Okay, all the way around. And so my final perimeter then is, now this is just about, do you know what to do with like terms? Okay, so if you add 12 and 12, 24 and 10, 34 plus 5 is 39, it looks like. And then I have 5 root 2's. Remember, adding a S on the end helps you. Think of it as like 5 x's. You wouldn't add 39 and 5x together, so it's 5 root 2's plus 5 root 3's. Okay, that would be like 5 y's. And if they give you units, put in the units. If it was like feet, put feet. But those are not like terms. They do not combine, guys, so get used to seeing answers that look like that. That is your perimeter. Okay, so obviously that old stuff, 30, 60, 90, 45, 45, 90, all of those things are coming back to play. Okay? All right, you have what you need. Good luck.